Hi, this is Prasad from Civil Engineering Department, bearing with the employee ID MLRS 10403 MLRITM Engineering College. So let us go through today we have discussed about the tacheometric surveying. So in this classification of surveying based on the instruments like chain surveying and compass surveying, plane table surveying and theodolite surveying, leveling of instruments, and let's go through the tacheometric surveying. In this tacheometric surveying is the advanced instrument for the leveling of the theodolite instrument. In this tacheometric surveying, this survey is used to determining the horizontal distances and vertical distances by using the tacheometric instrument with the help of the stadia intercepts of the stat. Let us go through what is the definition of tacheometric surveying. In this tacheometric surveying, the horizontal distances and vertical distances and vertical angles are measured by the tacheometric surveying. Next, this method is very rapid method for the survey the topographical maps and for example rivers and irregular boundaries on the earth surfaces. It is used to measure the survey the topographical maps like contour maps, etc. Next, instruments used for the tacheometric surveying. In this tacheometric surveying, what are the instruments required for the leveling on the ground surfaces? First, we have to take up on the leveling of stadia, staff rod, and instrument, tacheometric instrument. In this tacheometric instrument, the instrument having the foot screws of the instrument to fix the bottom of the instrument, and I have to fix the spirit level tube. In this spirit level tube is used for the leveling of the instrument on the tripod stand. Next is the graphical representation of the cross section of the tacheometric surveying. In this tacheometric surveying, the lenses are measured inserted in the telescope. So the objective vane of the telescope is lens. Lenses are inserted in the objective vane of the tacheometric telescope. This is the horizontal axis. Horizontal axis. This is the focal distance. This is the focal distance. The distances between the instrument to the staff. This is the focal distance. Next, coming to the center point of the instrument to the object. This is the distance. It is measured with the tape or chain. Next, this is the graphical representation on the ground. We fix the instrument to the staff or any objective. To fix the instrument to the leveling of tripod stand, and to fix the instrument, to fix the adjustments of the foot screws and spirit level, accurate leveling, to fix the readings from the objective vane of the telescope to the stadia diaphragm. So this is one of the main principle for the tacheometric surveying is distance equal to Ks plus C. K is equal to constant. K is equal to constant of the tacheometric surveying. S is equal to staff intercept values. C is equal to constant values. Next, coming to what are the uses of tacheometric surveying? In this tacheometric surveying, what are the uses? It can be measuring the horizontal and vertical distances on the elevations on the ground surfaces, unlike hilly areas, terrain areas like mountains, etc. Irregular shape like forest areas also, it can be irregular boundary shape on the forest areas. Some undulations acting on the earth surface. It can be measuring the elevations and also horizontal distances and vertical distance by using the tacheometric instrument. So preparation of topographical maps which require both elevations and horizontal distance. This is the first point of the first use of tacheometric surveying. Next, coming to the survey work, it can be difficult to survey the land surfaces like forest areas, hilly areas, terrain areas, hydrographic methods. Next, detailing the filling, cutting and filling areas, something so hilly areas, valley areas. It can be survey is very difficult to measure the distances. So recognizes the surveys, the highways, railways, etc. Checking the already measured distances should be done in the tachyometric surveying. Next, hydrographic surveys like large water bodies like rivers, ponds, oceans, etc. Next, contour maps. Next, what are the advantages of tachyometry? What are the benefits by using the tachyometric surveying? First point is tachyometry is used where the chaining is difficult to measure the distances on the earth surface. So on that situations you have to preferring the tachyometric surveying. Easily you have to find out the measurements to be noted on the measurement book. So next, coming to the, it is used the preparation of the contour maps in the earth surface by using the tachyometry. Next, it is used for the survey the roads and railways, bridges, etc. Next, it is also used for the hydrographic surveys also. It can be used. Next, coming to the, it is used where the accuracy is more required for the that type of survey by using the tachyometric instruments. It saves the time and money. In this, tachyometry is used for the survey the land records. For it can be more benefit for the minimize the time and money. Next, what is the principle of tachyometry? The main principle of tachyometry is d1 by s1 equal to d2 by s2 equal to d3 by s3. Distance, d, it can be instead of distance 1, distance 2, distance 3. S1, S2, S3 staff intercept values. S1 is the first staff intercept value. S2 is indicated by the staff intercept value 2. Next, S3 is staff intercept value 3. This is the telescope. S1 staff, S1, S2, S3. These are the staff intercept values. This is the diagram of the telescope. Next, tachyometric surveying, the main principle, mathematical formula. D is equal to F by I into S plus F plus D. This is the F by I is indicated by the multiplying constant of the tachyometric surveying. F plus D is the additive constant for the tachyometric surveying. D is the distance. Distance formula of the tachyometric survey is the most important for the calculation of the additive and multiplying constants of the tachyometric survey. Next, in this tachyometric surveying, what are the instruments should be used? Telescope, spirit bubble, and tripod stand, and staff, and the observations are should be noted on the ground. Next, theory of stadia tachyometry. Stadia is inserted in the objective vane of the telescope. This is the objective vane. It can be lens should be inserted in the telescope. This is the S. S means staff intercept values. So V is reading the staff cut by 3 hairs, cross hairs. The lens should be inserted in the crosshair should be identified. So bottom and central top of the diaphragm. So I is indicated by the length of the image. S is equal to staff intercept. This is the S value. F equal to focus. Focus means focal distance between the objective vane to the eye vane. Next, V is equal to vertical axis in the instrument. F equal to focal length of the objective glass. Next, coming to the small d is indicated in this figure. Distances between optical center and optical axis of the instrument. Next, coming to the mu is the distance between the optical center and staff. Next, coming to the V, the distance between the optical center to the image. Like where we have to survey the instruments or image or anything else. So this is the indications of the stadia of the tachyometry. Next, what is the definition of tacheometry? Tacheometry is a branch of science. It can be used for the horizontal and vertical distances by using the tacheometry. The type of survey is known as tacheometric surveying. The instrument used for the tacheometry is ordinary transistor theodolite is fitted in the instrument. Stadia diaphragm is generally used in the tacheometry. The principle of tacheometry is the primary means isosceles triangle. It can be isosceles triangles are the inserted in the telescope to the objective vein. So this is the isosceles triangles are inserted in the ratio from the apex from the basis of the always should be constant. D equal to F by I into S plus F plus D. So F by I is focal length by image into S plus F plus D. This is the additive constant. This is the multiplying constant of the telescope of the tacheometry constant. So formulas should be solved. Solve the examples in the tacheometric surveying. In this mathematical formula is a distance equal to F by I into S plus F plus D. F by I means multiplying constant of the tacheometry. S is equal to staff intercept values. F plus D is the additive constant of the tacheometry. Focal length distance plus distance between the optical of the image to the instrument lens. So uses of tacheometry: preparation of topographical maps and which require both the elevations and horizontal and vertical distances should be measured on the earth surfaces like terrain areas, rivers, etc. Survey work is very difficult to the note the measurements on the earth surfaces. So it can be very difficult to survey the land. On that time, we have to preferring the tacheometry instrument should be used and find out the horizontal and vertical distances should be easily noted on the ground. So detail filling, reconnaissance and surveys on highways, railways and bridges, etc. So hydrographic surveys should be noted in the survey. Establishing the secondary contour. Next, methods of tacheometry. These are the two methods, stadia method and non-stadia methods. So first one is fixed hair method, second one is movable hair methods. So in this stadia hair method is tangential methods and substance bar method. This is the movable hair method. In this stadia hair method, not fixed. Stadia hairs not be moved, adjusted with the micrometer screws. That type of hair method is known as movable hair method. Next, stadia method, it can be denoted in the fixed hair method and movable hair methods. Next, coming tangential methods in the tacheometry. No stadia hairs is not required for the inserted in the telescope. Leveling stuff targets at known the distance. Horizontal and vertical distance are measured in the angles. Some cases discussed in the ground levels. So the key points of the tacheometry is additive constant and multiplying constant of the tacheometry. Thank you.